So, hi everyone. Welcome to the Encode Urbit Hackathon, the first workshop, Urbit as a platform, which will be given by Neal. It would be lovely if you put your cameras on so we can see you. It'd be really nice, make it feel more together. I will drop a few links in the chat once we got started, just all the stuff you need in case you haven't signed up or haven't joined the Discord. But for now, that's everything from me. So I will pass you over to Neal to talk about Urbit as a platform. Thank you, Neal.
All right, fantastic. Thank you. I am also comfortable screaming into the void as these things go, having done a lot of online teaching at this point. So we have an interesting challenge in front of us, which is we have 6 weeks of competitive programming. Now, competitive programming is different from regular programming, not in that you don't need to move quickly with regular programming, but that you are probably trying to use common code patterns and canned troubleshooting without as much time for intensive testing that you would have in regular software development. Basically, right, you have to be able to move quickly. So my objective over these 3 workshops that we're hosting here is to give you a feel for what the components of Urbit are as a platform and how they interact with each other. That's really what I'm aiming for today. We're not going to really look at much Urbit code, if any. We're going to be talking about the architecture of the system and how this impacts the kinds of things you can do on Urbit. The next workshop, will be focused on how do you build an Urbit app, and it will be looking much more deeply into the code. And then the third workshop will focus on brainstorming a lot of app ideas that are sized to the kinds of things you could complete in 6 weeks as part of a hackathon project, right? Like what would be a competitive product to come out of it? Because one of the problems, right, is that coming into a new platform, you don't know what's easy, what's hard, what's low-lying fruit that has already been done, what's low-lying fruit that has not been done, right? Like what's something that's fairly easy that someone has just never bothered to do yet. So I'm gonna try and highlight that for you and make that clear what's going on. Now, as we look at Urbit as a platform, one of the first things I want to answer for you, some of you have started playing around with Urbit already, but I want to answer for you, what does it look like to actually run Urbit, right? Like when you're at the end of the day, you go ahead and you run Urbit. It's going to depend on how you start running Urbit when you interact with it for the first time. Let me see, there's my console. Okay, here we go. Okay, so here's a console. If I start Urbit, if I'm running on a Mac or a Windows, or a Linux machine, then when I start Urbit for the first time, it will boot me into the command line interaction with Urbit. You know, like if you're working on a cloud machine, this would be fairly straightforward, right? It's like connecting to a Docker or like a Hadoop or one of these older big data computing processes. And you know, we can type things here. It's like Bash. It's kind of more like Conch if you've worked with Conch, which is a Python shell, because Python is part of the shell and it can evaluate shell commands, so it gets you both for free. So this is a regular REPL read, evaluate, print loop you can interact with and type and do things. So you have certain codes you can do, which would allow you to access and work with it by synchronizing the file system or making these, you know, like regular system call, system daemon types operations. And then there are operations where, you know, you can actually write code, right? So here's a Lisp-like syntax that I'm employing here to add 2 numbers together. So with parentheses, add 1 and 2. Like I said, we're not going to get deep into code today. We're going to save that for next week. But this is what it looks like to actually run things. Now, presumably, when you start working with Urbit for the first time, you're going to be working with what's called a planet. I'll get into what the difference between a planet and a star and a comet and all these other things are a little bit later on. But you'll be working with a planet which will have 4 syllables rather than I've got 8 here in my name. And so this will be the way that you'll access this. If you've started running something through port, that's fine. Port is more aimed at users that are not developers. So at some point, you will probably want to start working on the command line with Urbit as well to get comfortable with what it can do. The other major interaction mode that you're going to have is going to be via the browser, which you will find if you're running it locally. If you're running it through Port, then Port will expose the browser interface for you. Otherwise, you'll need to navigate to localhost and take a look inside of your browser at what's there. Most likely, it will ask you for a password. It'll present a login page with the name, and it'll present a password. You can get that by typing plus code here at the command line. I won't press enter because this is a real chip and I don't want to expose the randomly generated password there, but plus code would give you that information on how to log in. Now, when you go into the browser, let's see, is this the right one? Yes, it is. All right, when you go into the browser, it's going to expose something like this. There will probably be fewer apps installed when you do this for the first time. That's fine. You can, if you know where a software provider is, then you can poke around and actually locate those. There's an urbit.org/ecosystem page that will show you app providers and apps that are already available on the network. But if you click into one of these, groups is probably the one you'll start with. Then this is the chat forum. It's like a Slack or a Discord or just an old school forum. And this is, so Hooniverse is the main one that we use for beginners to the language. I'm going to be bridging the hackathon channel here over to the Discord, and then you'll get a look at what that looks like. So you'd be able to join and interact with any of these and be present on the net on both networks using the Discord bridge channel. So this is what Urbit looks like as a system. It's kind of like a mobile device. It presents a bunch of pages where you can interact. There's games and things like this that you can hunt for the way that things are working. Keep working with it. And when you develop applications that run on Urbit, one of the options that you have open to you is to write something that talks to a front end. So it's kind of like writing a conventional server backend, and it's in the Urbit way, and connecting it to a conventional front end, React, JavaScript, whatever you want to do there. It can speak plain HTML. So for serving pages, that's fine. If you want to write something that's actually an interactive web app, then you have to do something a little bit more complicated. But many of you have already run into that with front-end development. Anyway, so I'm not a fan of JavaScript myself, so I don't do a lot of front-end development, but I will write HTML and stuff when I need to. Now, let's go back to Urbit as a platform. What does Urbit get us as a platform? This is sort of my summary for why are we bothering? Like, what is Urbit trying to do? Well, as we look at the different components of what Urbit is as a development platform, one of the first things that it exposes that you've run into in some sense is that it has cryptographic identity. There are a lot of people working on the self-sovereign identity problem, right? The problem of how do you have a persistent identity that you can attach certain kinds of information and long-term state to. Some people are doing this on-chain. Some people are trying to do this off-chain. Urbit is basically an off-chain or parachain solution that solves this problem for you in a way that you can use elsewhere. The main component of Urbit ID is what's called Azimuth, which is a set of smart contracts that are built on Ethereum as a layer 1 and a layer 2 rollup together. I'll talk a little bit more about that later on, but anyway, we have a public key infrastructure that you're able to use that's built into the platform here. Using Urbit OS, which is what I was just operating, we also have peer-to-peer, end-to-end encrypted apps with state essentially as a persistent database. We have these things visible to us and available to us as part of the platform. So it's not, like one of the things that people get wrong all the time, for instance, is passwords, right? Like how many times is a service compromised? You get these emails where, we've had 5 million user IDs leak, and you go digging around and it's something like they're transmitting passwords in plain text without salts, or these kinds of, this kind of nonsense. Like, so there's a lot of places where there are best practices that are known, but they are, they're enough of a gumption trap that people don't bother to actually implement them. Urbit as an operating system is trying to implement a lot of these for you so that you don't have to worry about that. Peer-to-peer connections already present in the system. End-to-end encryption is built in, and you would actually have to do some hacking to figure out how to get around it if you wanted to transmit things in plain text for some reason. You also have the direct software distribution, so you get true peer-to-peer software distribution. Different people host their own app aggregators, kind of like an app store where you can make things available, but there is no centralized corporate oversight on what is taking place with software distribution. So if you write something, you're free to distribute it and build whatever kind of community that you'd like to on top of that. And then with this, you get an HTTP interface, a UDP interface, some other things. You're able to interface with traditional web clients and Web 2 services and build things that work with those as well. There's additionally a site, developers.urbit.org, that goes into great detail about every aspect of what it looks like to develop on this system. So I will use that more on next week in the second and third workshops when I talk to you about what's going on. Now, the two things that I've named here that are parts of Urbit are what I've called Urbit ID or Azimuth and Urbit OS or Arvo. So they have an internal name, Azimuth or Arvo. If you call it Urbit ID, Urbit OS, everyone will know what you're talking about. So, call it those and you'll be just fine. If you've programmed with a scripting language like Lua inside of a modded game, for instance, if you've worked with scripting a Unity engine, you're familiar to some extent with how the game serves as a platform. It provides correct primitives to speed up your development. And Urbit does this for the operating system layer. So an older operating system like a Unix or a Unix derivative, so Linux and Mac OS, they provide a lot of guaranteed primitives around, like, this is what a user is, this is what user permissions look like, this is what a file is, and it manages certain aspects of how these things are put together. One of the critiques that can be made at this point is that the fundamental way that Unix treats these things is rooted in 1972, right? Like there are things like file access control lists, FACLs, and other things that have been built on as secondary kludges to solve problems that have arisen since the original specifications were written. Urbit is an attempt to write an operating system layer which incorporates a lot of things we've learned about personal data management, social media, user apps, security, blockchain, and so forth, so that they're available to you when you start writing and working with the system. Now, a brief digression here on virtual machines, right? So computer chips act as a platform, right? They're a platform in machine language. Due to architecture differences, we cannot use assembly language portably. So we can write something in machine language or assembly language, things like Roller Coaster Tycoon, even, right, is famously written in assembly language. Most people don't want to write in assembly language. So you're able to take a look at what's happening with sorry, I was reading the comment there. I'm not sure what that means. That's gone wrong there for you. You're able to write things in assembly language, but then it's tied to one particular architecture. You don't have the flexibility to resolve this across all platforms. There's two basic solutions to this problem. And just picking a higher level language doesn't necessarily solve this problem, right? So if you're writing a program in C or C++, you still have to compile for a specific target architecture, right? So the two solutions that have historically been employed to try and target all the different kinds of architecture that you may run into, some of these are old, some of these are new, is to either, this is my generic fake software company here, Finordsoft. You can either compile a per chip version of your software for a set of supported architectures. This is what is most commonly done now, where if people want to run things on different architectures, They simply compile it for different architectures. You see this with mobile devices a lot, where some people are building for the iOS chipset and everything, and other people are looking for the Android and ARM. Well, I mean, they're all ARM, but you know what I mean. There's different assumptions that are made about what's going on here. All right. The other approach is to develop what's called build a virtual machine layer. Today, when we say virtual machine, we're often meaning a cloud instance that's on the somewhere on the cloud. That we spin up a virtual machine on AWS or DigitalOcean, and it means that it's this virtual machine that we can interact with as we go forward through everything. The older interpretation of virtual machine meant that you were building an interpretation layer that would allow your software to be agnostic to your hardware. This was originally the promise of Java. When Java was developed in the early 90s, they wanted to develop it so that they would write a Java virtual machine for every architecture, and then anyone who wanted to write a Java application would be able to run it on the Java virtual machine. And this has been carried forward in various ways, right? Ethereum virtual machine means that you can write a smart contract that runs on Ethereum, and you don't need to worry about the architecture of the system that you're running on. You know that it will work on Ethereum, and Ethereum is built to run on different kinds of hardware. That's all you need to worry about. Urbit as a system adopts the second approach, and it's going to run on a particular virtual machine called Nock. Now, once you have a virtual machine, you can sort of think of that virtual machine as the target architecture, right? So Python compiles to bytecode, and you can run bytecode on something that can run Python. A lot of systems use some version of this. Urbit does it with Nock. It's a minimalist Turing-complete language specification, much like assembly language or JavaScript or Java bytecode or everything else. You don't need to know any Nock to effectively use the platform. It's very minimalist. This is the entire specification plus the other page that has the interpretation of the symbols as what's going on here. So it's a hyper minimalist specification related to combinator calculuses and other things that, if you've had a CS background, you've probably had to drudge through these things at some point in one of your classes. But outside of formal fundamental computer science mathematics, no one really builds in these things. So Urbit OS runs on Nock, and it's this language specification. So everything running on an Urbit instance, or what we call a ship, is ultimately compiled and run as Nock. So we'll circle back around to Urbit OS after taking a look at Urbit ID, but this is where Urbit OS is coming from. Now, Urbit ID is a separate identity system. It's bootstrapped on Ethereum, as I said, as an ERC-721 token with L1 and L2 components. It's a public key infrastructure, meaning that when you own an instance in the address space of Urbit, right? Urbit ID is an address space, and it's a public key infrastructure attached to that address space. When you own a point, what it means is you possess a wallet that you can use to log in and carry out executive actions with the point. You can transfer to someone else or so forth. And you have a private key that's generated when you launch your ship for the first time. When you start up your Urbit instance for the first time, you will have a private key. So any message signed with the private key is decrypted using the public key. Since this is built into the system, it avoids a lot of the pitfalls that people run into using GPG and trying to set up these kinds of manual encryption and so forth. The Urbit address space is divided into several types of points or addresses. This is true of the conventional internet as well, where you have top-level domain providers, and you have ISPs, and you have internet backbones. For us as end users, this is mostly transparent unless we're actually doing really deep stuff working with the TCP IP protocol or something. We don't need to worry about this. And similarly with Urbit, although the naming scheme makes it transparent to see what's going on, for the most part, we're not going to have to worry about this, but it's useful because people will talk about these. So you need to know why is it called a planet? Why is it called a comet? A galaxy is like a top-level domain. It's a network routing for the entire system right now, although stars will eventually take over more of that as the network grows in size. It's responsible for software distribution. It's responsible for network governance. Similar as with the current TCP/IP World Wide Web Internet, there are certain standards bodies that corporations and countries have members on that actually sets the ways that internet components talk to each other, the way that they're allowed to talk to each other, what the protocols look like, and so forth. So the galaxies play this role within Urbit. Stars provide some other network infrastructure and to some extent act as aggregators of communities, but right now there's not a lot else going on with them. Planets are the main one that you're interested in right now. This is an individual identity. So it is, it's cryptographically yours. You own it. You have a wallet. You can prove that you own it. Any message signed with your Planet private key is decrypted using your public key, and everyone can see that it's you. You can prove that it's you. The other common one in use is a comet, which is a transient ID. Some of you may have set up comets if you haven't acquired a planet one way or another. Comets, the possession of the comet is de facto its public key. It doesn't have a wallet that's associated. So anyone can spin up a comet for free, set it up, run it. But it's kind of like a bot looking account. Like, sometimes you look at an account on Twitter or something and it looks like a spam account or a bot account. Maybe it is, maybe it isn't, but it kind of looks lower reputation that way. So planets are kind of the core identity as you're building this. The other point I need to make about address space is address points are mapped to a nonsense mnemonic scheme, which allows for easy reference to numeric points. So every number has a unique name based on its modulus 256. And so we're able to distinguish points and point roles as we do this. So galaxies are 1-syllable names, stars are 2-syllable names, planets are 4 syllables, and comets are 16 syllables. And we call this a PAT-P on the network. So if someone asks what your PAT-P is, this is your spoken point ID. Again, you don't need to know a lot of this to develop on the network, but I want you to feel comfortable as you interact with people as you do this. Now, Urbit ID consists of a set of smart contracts on Ethereum, as I mentioned. These support ownership interactions like dApps, attestation claims, reputation censoring, delegated transfers. There's subsidiary hosting operations that you can do and so forth. These Urbit ID on-chain contracts and elements have been completely audited for security. So they are considered, completely audited and secure. And so one of the things you can do if you want to work on Urbit is you can focus on building tools that interact with Urbit ID and provide useful things for Urbit ID, but don't really talk to Urbit OS. So you could write a dApp or a UX or something that interacted with these in a useful way. Okay, that's fine. That's a thing you can do. That if you know Solidity or so forth, then you're able to do that right out of the gate. You don't need to know anything deeper about Urbit and Urbit's programming language to work with this. Okay, circling back around to Urbit OS. All right. I'm going to divide this into the kernel and the user space. To sum up the platform to this point, an Urbit ship is a running instance of Urbit OS, which is cryptographically linked to an Urbit ID. So what I'd like to look at now is what does Urbit OS look like for a user or developer? Any operating system has a kernel that provides system services with which user processes can interact. These include, file systems and timers and a lot of the things that are running in your system tray. Some are user space, some are kernel, system monitor, these kinds of things. For Urbit, everything that I've labeled in bold here, the top 4 components here, are what I'm going to consider the kernel. These are the parts that you can rely on being present whenever you are writing software on Urbit. The core part of Urbit, the innermost part, is, as I said, the Nock specification. Nock instructions are executed on a virtual machine interpreter, a runtime executable, which runs on your particular hardware. Currently, we build a runtime for x86-64 and ARM64 architectures. We can build it for others in the future. We probably will. Right now, we target those two platforms there. On top of Nock is the language specification for Hoon. Hoon is the language that you will actually use. We don't write things in assembly most of the time unless we're bit blitting on a particular display system within C. Most of the time we're going to write C. Hoon is Hoon is Urbit's C. So Nock is the assembly language layer. Hoon is the C-like language layer. And so Hoon compiles to Nock, so we have to have the language specification to do anything. On top of that is built the main event processing loop. Urbit OS, the main component is Arvo, which is an event loop, all right, and a state machine. Urbit is a functional operating system. And functional in this case means functional as in language, like Haskell or OCaml or a Lisp, most like a Lisp. Arvo is largely invisible to you, except that you will be constructing events that are going to be evaluated. So when you write an expression, then this becomes an event that gets evaluated. So as an app programmer, these are deeper bits of lore in a sense, and some of these you'll need to be aware of. You will need to learn Hoon if you're going to develop apps on Urbit, but otherwise you probably don't need to be aware about a lot of the details of this for a hackathon tier, a hackathon scoped project. So Arvo is the state machine and the event loop. It keeps a queue of incoming events. It processes them. It's single threaded. So it is essentially like mathematically well-defined set of operations to proceed from one state to another. The next layer up provides system services. This includes HTTP server processing, peer-to-peer communication, public key lookup, the file system, building code from disk, and so forth. These are what are called veins in Arvo, essentially system daemons. You can think of them as that. And these are things that Arvo events are able to take advantage of. This also instruments all of the end user apps, which is the bottom piece here. This is in light text here. This is the place where you'll be working if you write things for the hackathon on top of the Urbit platform, Urbit OS directly. These are where end user apps and middleware live. So we call it user space. It just means any part of the system that's outside of the kernel. Urbit apps, they're built with a highly formal structure. We're going to call these agents when we talk about them at the next workshop, but essentially it's an app, right? It's an app process, and it allows the system and other apps to make certain good assumptions about where data are located, how the agent will respond to certain kinds of interactions, and so forth. So it feels very formal. There's a user space app framework which requires a standard application interface. Like when you compile something in C, if you run GCC by itself and you don't give it a -o for an output name or whatever, then you'll get like an a.out file if you're writing in C or C++. And part of what makes this a binary executable that you can run on your system is that it has a certain determined structure inside that tells the system, tells Linux or Unix or Mac how to load this into memory, and then where the first command for it to start executing is located. Okay. Urbit is doing something similar here. There's an app framework that means that whenever it looks at an arbitrary app, it knows how to pull this in. So it's going to give you access to the state management and the peer-to-peer communications and everything else that the operating system gets you. Urbit is designed to work as a personal server. Let's see. I'll leave it on this slide for now. Urbit ships have unique attestable cryptographic identity. I've said that before. They store data and program state. Since Urbit has a built-in database, no external database is necessary to provision. It's part of the system. So if you're treating Urbit as a server process that you're writing, that something that's going to serve pages to the web, serve things that other things will interact with, the database is built in. There's a file system which will synchronize with your host operating system. kind of similar to the way that something like Docker might do it. It can speak HTTP as both a client and a server, and it supports JSON and HTML, XML, all these kinds of things. So it can serve pages and web apps and so forth. So we're able to build and work with those. Now, some other points to consider as you think about approaching this. I've given you an idea of what the architecture looks like here. Urbit is a purely functional operating system. So events are processed and then written to disk. And so state is a pure function of known enumerable events. When an Urbit process is running, I think Docker, like a Docker container, is a reasonably good analogy if you have worked with them. There's no distinction between primary and secondary memory, and the operating system and apps can update themselves while running. They use hot code reloading, so it's sort of like doing a lobotomy while you're running on the fly. If you need to update something, you define an update path for the state machine that's present, and it will follow these steps and update itself online. So the operating system will do updates online. It will slow things down a bit while it's updating, for instance, but once a month, maybe someone sends out an update. But you actually don't have to shut things down and install things to stand things up. Same things with apps. If you push an update, everything is built on a pub sub, a publication subscription methodology. So if you update your software, then everyone who installed your software and is still subscribed to you will receive those updates. So to the end user, it looks very seamless to update things. Because Urbit is a functional language, functional operating system environment, all data structures are immutable and persistent. From a CS perspective, one of the attractive things is that this allows us to think about things like shared libraries without the trouble that static versus dynamic linking introduces on many platforms. It is Lisp-like in that code and data are homoiconic. They're convertible to each other. Like code and data are the same thing, right? If we have a data structure that is also valid code, then we can evaluate it as code. It doesn't matter to Urbit if it's compiled into Nock, then it can be treated as if it were Nock code. The Nock language was a hyper minimalist set. So if you think back to the old days of the 90s or 80s and 90s, there was this huge debate going on between reduced instruction set chips and complex instruction set chips, RISC and CISC. And the people pushing for reduced instruction set chips were arguing that by minimizing the number of operations that are available in the machine language on a chip, we can write faster, more efficient software. And the people that were pushing for CISC chips, for complex instruction set chips, were arguing that providing more compound instructions would lead to a faster chip. As history played out, complex instruction set won, and it turns out that it's faster to bundle things. In many cases, given the other assumptions about chip architecture that we've made. Now, Urbit is a RISC, right? It's a reduced instruction set chip, instruction set. Anyway, it's a RISC, right? A reduced instruction set. Urbit gets around the limitations of this because it can optimize slow Nock code using fast C code in the runtime where appropriate. We call this jet accelerated code when it takes place. We don't do it for everything, but for certain operations that are elegantly expressed mathematically in one way, but would be inefficient to calculate in that formal specification. If you've looked at like a lambda calculus or something, then you'll know what I mean there. Otherwise, it's sort of like saying if I wanted to add two numbers, I would have to add one to one number again and again and again until they're equal to each other. It's beautiful mathematically. You don't want to do it in practice, right? You don't want to do that. So the runtime will optimize over these slow cases as well when that's necessary there. So it's more efficient than just a reduced instruction set architecture would imply for you. Now, at this point, let's think a little bit about what it would look like to build an Urbit app for a hackathon. And I'll get deeper into these I guess, at the third workshop. But your 4 basic modes that you can approach this are. One is you can do on Urbit app development. This would mean learning Hoon and a little bit about Urbit OS and building something that's fully integrated into Urbit as a system. This is effective. It's high leverage. Urbit development is couched in terms which are probably unfamiliar to most programmers unless they are already versed in something like APL or Lisp. If you've worked a lot with a Lisp, I think you'd be comfortable with an Urbit. If you've only worked with Python, it's probably, or JavaScript or something like that, it's probably going to take you more mental effort to dive into it. It's going to feel like a functional programming language with an overlay of imperative syntax on top of it. That said, I do encourage you to seize the nettle. This is probably the highest leverage kind of thing you can do on Urbit, is to write an app that actually runs on Urbit directly. And it would require learning some Hoon. So we have some docs. I'll point at those in a moment. I think you'll find that Urbit is refreshingly different from a lot of the other platforms that are out there, but still allowing you to have rapid application development and deployment as you work with it. The next thing you can do is you can do something that talks to Urbit. All right, Urbit adjacent app development would mean something like a front end user interface. So, write a JavaScript web app that knows how to talk to an existing Urbit tool. And it speaks JSON or HTTP, put GET post requests to it. And you actually just need to know the HTTP interface for it. You don't actually need to know any Hoon to do this. If you form a team where someone knows Hoon and someone knows front end, that's a fantastic way to work as well. Another thing you can do is you can focus on building something that it works with Urbit ID, as I mentioned. So you could build dApps or user interfaces that work with Azimuth contracts that query the state of Azimuth and interact with it. The one caveat about this is that because of the layer 2 rollup, most of Azimuth is layer 1, but there's a layer 2 rollup that gets bundled on there that is not transparent from chain state of Ethereum directly. So you will need access to a running Urbit instance that has a JSON-based interface so you can hit it with an HTTP JSON request, and it will tell you, it can report to you back out in JSON the status of the entire Azimuth public key infrastructure, L1 and L2. So that's the caveat there, is you will want to figure out how to talk HTTP and JSON to that particular Urbit process. And then the other thing you can do is you can build a bridge app, right? Urbit is well equipped to talk to a lot of Web3 chains and tools. So, if you have IPFS, if you have Ceramic, if you have Cardano, zillion other things, building a bridge app between Urbit and a blockchain is pretty high leverage and valuable kind of operation to do. Now, I'm going to be talking next time about how to build an app on Urbit. That's where my focus will be here. So this Hoon School and App School are the written docs that I will refer you to, that really covers first what the language looks like and then what it looks like to build something in the language. If you're going to write on Linux, you need to know C, and then you can, or C++, and then you can write on Linux. So you need to know 2 things, right? You need to know the language, you need to know the operating environment. We're doing the same thing here with Hoon School and App School in the docs. These are at developers.urbit.org. To write something adjacent to Urbit, something that talks to Urbit, you would check out the app workbook, in particular the flap exercise, which is included there. App workbook is attached to App School, and it includes annotated tutorials of how to build several things within Urbit, things that talk to Urbit. And then there's an Urbit Visor Chrome browser plugin that DC Spark put out last year. That is, if you are comfortable writing extensions in Chrome, then that's one to investigate as well. So Urbit Advisor takes care of the Urbit interface for you, and then you're writing something that is like a conventional browser extension that utilizes that and therefore knows about Urbit identity and so forth. If you'd like to work with Urbit ID, then in particular, check out the Azimuth docs, which are at the github.com/Urbit/Azimuth. And there's a lot of different sets of smart contracts that are involved in Azimuth. The ones you care about are the ecliptic smart contracts, because these actually have to do with point interactions, conditional transfers, sale, all these kinds of things. And then, of course, a bridge app means probably means some of the first on Urbit app development, but it also means, you know, whatever your native language is coming into this project and looking at what's going on here. Okay, so you can also, if you're interested in building on Urbit, ahead of the next workshop, able for you to take a look at, there's a trio of rapid tutorials on developers.urbit.org we call lightning apps. They're in the guides. And these are basically 15-minute pages that just walk you through. They don't get deep into the language or anything, but they're just saying, like, here's the architecture of an Urbit app that is a friend group, that is a ring signature voting app, that is a, what's the other one we have? The other one's a chat room. And, you know, they all three of these talk to each other, but they're all just sort of capsule projects that show you this is what it looks like to build something with a specified level of functionality on top of Urbit. All right, and then of course there's other more resources in the developer packet that Encode has put together for you. Now, that said, what questions do you have at this point?
Maybe I'll get us started. Thanks very much, Neal, for the presentation. That was excellent. Really interesting. I wondered if you could talk a little bit more about the role of stars and planets and comets and what people need to do to kind of, from an entry level, to get started on Urbit. Okay,
so we'll start at Comet, because that's the kind of the easiest one to get, because you get it for free if you start up the instance. So you would download the Urbit executable from, well, actually I can walk through this. Start in front of the horse. So you go to urbit.org, go to get started, and then it has, what are you doing to get started? Now, one of the challenges for people getting used to this is, for end users, hosting is probably the best solution for many people. You know, like, I don't know how much hosting is, you know, $6 or $10 a month or whatever, and it's running on someone's hardware, and you have access to it. You own the wallet, but they actually provision the virtual machine for you and all that setup. So these are some of the things you can do. If you're going to be a developer, then it's more in the power user vein, and you want to actually run the command line app. Some of you probably run the desktop app as well. That won't work as well for a development environment, which I'll address in a moment. The command line app, it will walk you through, here's what you do for Linux, Mac, ARM, Windows, and so forth. So I'm going to take a look at Linux. There's one command here that I would run. And I've actually already run this. So for me, this would look, basically, it does a download and install and runs things there. All right, so this is me. Let me close this here. All right. So I'm on my regular system. If I want to run Urbit, mine is located in my binary folder. So I would do /bin/Urbit to run it. You might do /Urbit. That's the one that it suggests in the text there. If I run it by itself, then it gives me the standard, spits out the output on everything that it knows about here. And it gives me a lot of options here. As with, grep or something, there's a zillion options here. We don't care about most of these options for the things we're trying to do. The main thing that I have to do is I have to create a new folder for my ship, create a new Urbit. The peer is the folder that actually contains it, the same way that a repo is, the folder that contains a Git repository, for instance. So the peer is the one that we would do. /bin-Urbit/C. I can give it any name I want. This is the name of the folder. If I give it the name Comet, then it will go ahead, it'll download some boot instructions from the web, and then it will give you this slightly scary warning that it is mining a comet, may take up to an hour. So what it's doing is a comet has a blocker on it because we don't want bots to overrun the network, and these are the natural points that a bot would occupies. So what you have to do is you have to negotiate a connection to a sponsor. Someone has to sponsor a comment. So there's a few places on the network that will sponsor comments. So we're kind of sitting in that queue, and it'll take a moment. And once this actually hits, it'll fill up my screen with a whole boot sequence and give me that information. I'll go ahead and pause it here and not worry about it. If you are going to run a planet, what you will do is you'll get your planet however you bought it or acquired it from someone. There are people who give out planets for free. There are people who sell planets. Depends on if you care about things like what name your planet has and so forth. Since they're all mnemonic names, there's kind of an aesthetic component to the decision for many people. There's a way that you'll download a key file from bridge.urbit.org when you acquire the planet. These instructions are included with the sale of the planet typically. So you would go download the key file. You use your wallet to acquire the key file, which is your private key. So the public key gets posted, you get the private key, and then you'll use the private key to actually boot up your ship for the first time. So you'll use -key to do this. And so that would look something like -bin urbit what was it? Is it K -K mykeys.key. And then the other thing you have to do is you have to give it the name. So sample palnet is our mock sample planet here. And then give it a peer, a place to put it, and something like that. And this is how you would actually run this. Once this is launched for the first time, then you're able to interact with it via the browser and the command line, as I said. The one thing to be careful with, unfortunately, this is still too easy to do. It's not going to be as big of a deal with development ships, but it is a problem with people getting started for the first time. Do not accidentally boot the ship again with these keys. When you have run the keys for the first time, you should delete the keys. You will never need the private key again. It is now included as part of your ship. If you double boot, the problem is that it gets the network in an inconsistent state with respect to your ship. And the only solution for it is to reset your keys, which will cost you a little bit of Ethereum gas to do. So that's the one unfortunate thing about getting this started. Now, there was a question here in the chat about okay, there's a few questions. So there's a development environment question. I'm going to go deeper into that next time. The short answer is you can create what's called a fake ship. So Zod is the root galaxy. So if I do -F, it's a fake ship. It doesn't have a presence on the network, but I'm able to do development on it. This is the most common way that we will do development, is to just register a fake ship that has no network presence, has no keys associated with it, but still runs, evaluates Urbit code, Nock code, Hoon code, and so forth. Let's see. Someone said, is Urbit still on 112, currently on 112, or is that beta? I think we're actually on 113 and I have not updated yet. I think we're one ahead of this. So for the most part, as long as you stay mostly in sync, most versions, as with most things, are minor version hot fixes of, we found a memory leak that's critical on this one platform, that sort of thing. This is the way everything evolves, but every now and then there will be a major version update there. Let's see. Can we use other languages with Hoon? Oh, sorry, I lost it. Can we use other languages with Hoon using embeddings or libraries like CPython? Okay, so you can use anything with Hoon that you can use anything with Urbit that speaks HTTP. So if you want to write like a tornado server in Python that can talk to Urbit as a server, that's something you can do. Within Urbit, Urbit only speaks Hoon and or Nock at the current time. So you're not able to get on an Urbit ship and evaluate Python code on that ship. There's another question, can I develop Urbit apps while on Windows? Yes, your best bet for it is probably going to be the Windows subsystem for Linux, just because everything is built assuming a POSIX-like environment for the runtime layer. Urbit doesn't know anything about POSIX, like Urbit OS doesn't know anything about POSIX, but the VM interpreter that runs on your system that actually runs your Urbit does know about POSIX. So it's going to be happiest with a POSIX-like environment. What is the best language to write your app on to have the smoothest integration with Urbit? Hoon is number one because Hoon is what it does. If you're going to write outside, you will find the most resources aimed at JavaScript because of people writing front ends tends to be the most common mode for interacting with Urbit. So JavaScript is also a reasonable one. I would probably, if I'm thinking about team formation, if you're gung-ho about learning Hoon, fantastic, and reach out to me, and I'm happy to help you, point you at things, point you at videos, like whatever, like get you up to speed on it. If you're less gung-ho about learning Hoon, but you know JavaScript, you know Solidity, you know something else, you will probably be best off trying to form a team with someone who does know Hoon or who is themselves interested in learning Hoon. This is mainly the pragmatism of we have 6 weeks from beginning to end on this. You could probably get up to the language, up to speed on the language in 2 or 3 weeks if you really wanted to blitz it. That's correspondingly less development time. Everything's a trade-off, right? Everything's a trade-off when you're doing competitive programming like this. My short advice for how to approach challenges is to look at urbit.org/ecosystem and see the kinds of things that people have done. Everything's open source and it's MIT licensed. So you can riff off of someone else's project and, you would want to provide genuine novelty, of course, to make it a competitive hackathon project. But this gives you a feel for the kinds of things that are done, how big a project is to do certain, or carry out certain things. I think you'll find that Urbit programs are often shorter than you might expect them to be because a lot of things are done by the Urbit system. For instance, if you'd like to do a DigitalOcean setup, I believe there are some suggestions for cloud. Well, if you go to urbit.org/getting started and go to the command line instruction interfaces, it links a cloud hosting guide on operators.urbit.org. So let me just drop that cloud hosting guide for you there. Will there be more detailed judging criteria for the hackathon categories? Isaac, that's kind of a question I guess you and I would need to decide together. I don't know that we're going to have a very specific rubric. I think the titles kind of give over the sense of what we're aiming for in each case. There's like a best DeFi integration one. If you go out and you write like a plaid wrapper for Urbit, it's centralized finance, but like we take it as valid entrance to the contest, right? So,
Neal, I know you mentioned it a couple of times, but I was wondering if you could just talk a bit about the scope of our next workshop, just to give people a.
Okay, so what I'll be doing next time is a whirlwind tour of what Hoon is as a language and the assumptions it's making about functional programming. It adopts a paradigm called subject-oriented programming as distinct from object-oriented programming. This is a fairly intuitive way of handling scoping. I don't think, you won't get hung up on the fact that it's like this. You won't get hung up on that fact about the way that Hoon evaluates and deals with scope and everything. We'll do that very quickly, enough that you can read Hoon without getting lost when you look at it. And then I will talk about the actual architecture of a user space app. What are the assumptions that the system is making? And we'll probably build maybe 2 or 3 tiny toy apps that do specific things. Since every app has a predetermined structure and modes of interaction, you can poke it to do an interaction. You can peek at it to look at its state. You can subscribe to it so updates when it makes changes later on. There's only a few ways you can interact with really any app, right? Like if you push a button on a web app, you're initiating a one-time transfer of information or request for information. So these are the ways you can put these together to do it. So we will build some quick things, and I hope it will be enough for you to get a feel for what it is like in practice to build on this platform. Now we've described this platform, we're going to go say like, okay, what does it feel like to build something that interacts with this platform and actually takes advantage of the kinds of things this platform does. Now there's a question here about, is Hoon interpreted with a REPL? So there is a REPL, which is that command line when I first brought it up. But as with, something like Python or Ruby or R, we can write a file or a library and then run it, or we can write something that is a persistent process, which is we call it an agent, but basically it's a process that will stay alive and only respond to you when you have certain interactions that you want to do with it. So kind of like a single microserver with state is one way you might think of that. Yeah, there's some questions here about tutorials. I have written or posted a zillion videos about this at this point. So unfortunately, you have to go through me to get to Urbit if you want to learn how to program at this point. So I'm the first boss on the road to becoming a Hooner.
Yeah, I will try and collect all these links from the chat and post them in the Discord after the call. That is our time up, more or less. Thanks everyone for coming. Thank you so much, Neal. That was a great presentation. Thank you for answering all the questions. As usual, please get involved in the Discord, introduce yourselves, jump in teams. Any questions about the hackathon, you can set up a call with me. You can always message me on Discord, or you should all have an email from me as well. But yeah, that's everything. Thanks very much, guys. Thank you, Neal. And I will see you at the next workshop.